Welcome to the EASE workshop on Excel. The goal of this workshop is to help make you more comfortable with the platform of Excel and introduce you to some basic functions you can run with such. Know that at each step I present today, there are many options that you can take, so I encourage you to spend some time on your own exploring this software and the capabilities of what you can do with it. This is a hands-on workshop, and the data file can be downloaded from the EASE website, along with other supplementary documents. The URLs are shown here, or you can find them on the descriptions below. This workshop also reflects the PC 2016 version of Excel. Older versions or those of Macs may look slightly different, but the overall concepts should still apply. If you don't have the newest version, but you are a UNM student, you can get this for free from the UNM IT website. If you are using a Mac today, please download the guide to using Excel Mac that is listed on the EASE website to make it easier for you to follow along. Take some time to look through the pre-workshop materials found on the EASE website. This will complete Unit 1 of this workshop, which includes videos that cover a lot of basic actions within Excel, as well as basic terminology. You can always go back to these resources later if necessary, and the link back to this video is there too. Now, let's jump right into Unit 2. How to get information into an Excel file, basic formatting, and how to manipulate the data, including the use of equations or functions. Supplementary material on the EASE website gives you a walkthrough on how to enter data in formatting cells, as well as filtering and sorting, with a step-by-step presentation and script on how to perform each of these features. It also includes a few practice problems for you to do the functions on your own. It covers how to format cells, for example, adding borders or limiting the numbers in a cell to 2 decimal places. Most of the other functions are done using options in the Data tab, as seen in the screenshot here. Although both filter and sort are covered in the pre-workshop videos, we give an alternative take on this in the supplementary materials with how you can use the data we provided to practice these functions. For example, as a little teaser to this material, if you have data that is in a comma-delimited form, we discuss how you can effectively paste it into Excel so that the data is distributed across all columns, rather than in a single cell or column using the text to columns function. The supplemental material gives you a step-by-step on how to do this. Okay, now we get to work with data. If you haven't already, open the data set. If necessary, click Enable at the top so you can actually manipulate the content. The file should look something like this. The actual content of the data is not relevant for this workshop. It's the functions that we performed that are. But just of context, this data are various measurements of bears, including indications of sex 1 and sex 2. You will notice that there are 3 worksheets: the All Data worksheet, Stats, and Survey. We'll start on the All Data worksheet. I want you to take a second and scroll down quite a ways so that you no longer see the graph, but you can still see the data. Now, if I was to ask you what the data in column E is referring to, can you remember out of the top of your head? Probably not. To help with this issue, we'll freeze the top row in place while allowing you to scroll through the rest of your data. Be aware that whatever you currently see in the top row is what will freeze in place, so you need to first scroll back up to the top. If you are a Mac user, you can pause as necessary and follow the Mac guide, as well as the guidance provided by the Apple icons ahead and move forward. Again, the screenshots are for 2016 Excel for PCs, so to freeze panes, first select the View tab. Then Freeze Panes option. Lastly, then select Freeze Top Row. You can tell now that the panes are frozen because as you scroll, the first row stays in place, but the row number shows that you are moving through the data. And below the freeze point, the line is a bit thicker. Now that we have the headers in place, it is easier to work with the data. Click over the Stats worksheet and I'll walk you through what you're seeing. You have the averages first with the headers that match those on the All Data worksheet. This will come in handy in a moment. You can see that I already have the values entered for Sex 1. Sex is highlighted in pink. You will begin by finding the average values for Sex 2, starting with age in the bright yellow box. Regardless of which measurement the assessment is asking about, you need to calculate all the values because we are going to use them for graphing in a bit. Below this, you have standard deviation set up in the same way. I've done it for both sexes, but I will show you how I did it. Then, we will transfer some of these values into the table I formatted below, which separates the data by sex rather than calculation. You will notice that the headers in this formatted table do not include sex because that would be redundant information. We are transferring the information to this format because of what we want to graph. I will now walk you through how I calculated the averages for bears of Sex 1. To determine the average values for each measurement category, you make sure your cursor is in the desired cell, which in this case is the yellow box under the age header within the averages at the top of the worksheet, not in the table with borders. That is for later. Then type in equal average, open parentheses. The equal sign tells Excel you are giving it a command. If you don't have that, it will treat what you enter as text or values. The word average guides Excel as to which function you want it to perform, and the start parenthesis indicates that you are now going to tell Excel which values you want averaged. You'll notice that when you clicked over this worksheet, Excel added all data to the formula. That is because it is now referencing that specific sheet for the calculation. Your data is already sorted by sex. In the presentation, I have highlighted the ages of Sex 1 bear, but you will do the same for Sex 2. You can verify this by taking a look at the sex column, which I briefly highlighted with red. Now highlight all the cells for age of bears of Sex 2. Once you have selected the desired cells, you have to close the command with a parenthesis to end the function. You need to do this before clicking back to the stats worksheet, or the function will reference incorrect cells because it will switch the reference from all data to stats. When you hit enter, it will automatically take you back to the stats worksheet. You will find the average value should already be in the cell. If an error appears, verify that the correct cells and worksheet are being referenced in the formula. The average value you should see for average age for Sex 2 bears is 51.21. If this is not the value you have, verify that you performed this step correctly. Now, we need to get the average values for all of the other characters, but repeating the same process would be very redundant and take a lot of time. Instead, you can autofill the remainder of the values by dragging the function across all categories. Highlight the cell that has the formula you want. Then move the cursor over the bottom right corner onto the green square. The cursor should become a black plus sign. When you see the black plus with no arrows, click that and drag the formula across the cells you want values entered into. What this is doing is that it's shifting the reference along with the formula. So when you move from column A, referencing column A in the All Data worksheet, it then moves into column B and the associated column in the All Data worksheet. Once this is done, for those of you taking this with an assessment, you can answer the first question. For the standard deviation values, it's the same general procedure. Select the cell you want the value to appear in, which in this case it's the bright orange cell, and type in =stdev.s, open parentheses. For this data set, you want the standard deviation on a sample set, which is .s, rather than a population or the many other options available depending on the data you have. If you want more information on the statistical aspects of this presentation, please look through the list of Khan Academy videos that we provide on the EASE website. In order to move onto the graphing, we need to copy the values we calculated into the formatted table. We will use the Paste Special option. You copy with Ctrl+C or by right-clicking and selecting the Copy option. When you go to paste in the desired cell, do not do a normal paste. You need to right-click to see your alternative paste options. If you mouse over the image, it will tell you what type of Paste Special option that is. In this example, select the Paste Values option, the clipboard with a 1, 2, 3. This will only paste the values and not the underlying formulas. If you were to do a normal paste, the formulas would be copy-pasted and the reference cells would be shifted to reflect this change, giving you the wrong values. You can also select Paste Special and even more options show up. Take a second to paste the correct values from your calculations of average for sex-2 bears into the corresponding cells of the table. I've already set it up for all other values. You'll need the values here for graphing in a minute. Pay attention to your table headers and which values you paste in, because sex is in the upper tables but not in the summary table you are pasting the values into. So you'll have to copy and paste special in 2 sets for each calculation, from age through month, and then from head length through weight. To make sure you understand the purpose of this method, you'll also need to answer a question on your assessment sheet. All right, on to graphing. There are many types of graphs you can generate. The main ones you'll run across are column or bar graphs, scatter plots, line graphs, and pie charts. We'll cover how to create a bar graph and a scatter plot in this workshop, but you can always play with the others on your own. The first step to graphing is to determine the type of graph you need to use. To do this, first ask yourself, what do you want your graph to show? Also, what type of data do you have? Is it qualitative, which are categories, or quantitative, which are numbers? After you know that, you can then determine what type of graph is most appropriate for your needs. To help you out, I've created this graphic. So first ask, what would you like to show? For relationships, you have to have quantitative data because both the X and the Y require numerical values. For example, the relationship between size and heat loss. If you want to compare parts of a whole, you can do it either among groups or over time. Over time is inherently quantitative since time, the x-axis, is numerical, and you can view it with either a line or a bar graph. For example, how does the average rainfall change by month in New Mexico compared to Florida? To look at the distribution of values, you can do either a column graph or scatter plot. For example, number of people each year to use social media. Lastly, for the composition of something, you can look at it as a point in time or static setting, which will usually have quantitative data for qualitative categories, and you can use either stacked bar graphs or pie charts. If you want to see the change of a composition over time, then an area graph or stacked bar graph are best. For example, what is the composition of transportation for UNM students? What percentage use bikes, cars, buses, or other forms of transportation? We want to do a comparison, so there are a few other things you need to know before you can actually graph it. For column graphs, you need to decide what groups you want to represent. Excel calls this series. For the practice data, we will use series for Sex 1 and Sex 2. Next, you also need to know what your x-axis categories are. There can be numerical values or categories. We'll use body part measurements. Now I'll go through how to create a column graph. I'll walk you through the steps for Sex 1 and you will need to repeat it for Sex 2. First, make sure you click on a blank cell that is not adjacent to any values. If you don't do this, when you select a graph, Excel will attempt to predict the value range for your graph based on the cursor's location, and that can be a bit confusing. Now, go to the Insert tab. Select the column chart type. Make sure you select the 2D option because we are going to add error bars later, and the 3D option doesn't allow you to do this. Once you click on the visual setting you want, then a blank box should appear. Move the white rectangle that appears away from the formatted table. Now, we had to assign the data to appear in our graph. So, under the Chart Tools, select the Design tab. Now click Select Data. This is one point where different versions of Excel may look different, so keep in mind that the series are your Y values and the categories are your X values. Click Add to add a data series. First, we'll do it for Sex 1. Enter the series name, in this case, Sex 1. Then click the Select Data Range box next to the series value field. You can then highlight the cells with the values you want plotted. In this case, the average body measurements for Sex 1 from the formatted table. Then hit Enter or click OK. Your chart should have 8 columns. If there are additional columns, verify you got the values from the formatted table shown in the presentation. If the bar is too small, you can increase the size by grabbing any of the corners in the graph. Now, take a second and repeat the process for Sex 2 bears. Go back to the Select Data Source window. If you closed it, go back to the Select Data tab. Notice Sex 1 averages have been incorporated into the legend entries. Click Add and follow the steps previously described. Now, pause the video and take some time to incorporate the averages you calculated for Sex 2 bears. You should have both Sex 1 and 2 averages in a single chart. Now, we don't want the x-axis to show up as 1, 2, 3, etc., but instead as body part measurements. So, we click Edit for the x-axis horizontal values and do the same as before where we select the value range. Under Axis Label Range, you will select the header categories in the formatted table. In this case, it is the categories in our data table. Click OK or hit Enter. You only have to do this for one of the 2 data sets for it to show the information on the graph. At this time, the legend should be incorporated into the chart and your chart should look similar to this one. Remember that you can expand the chart if you need to increase resolution. Now, we will focus on understanding what error bars are and why it is important to incorporate them into your charts. Error bars are a representation of the variability of a data set, and error bars give an idea of how precise a measurement is. In other words, we get an idea of how spread apart the data points are. Let's take a hypothetical chart. The blue column is at value 25, while the orange is at 51. If we were given a data point that was 38, would we know which group it belonged to? We have to ask 2 main questions. Are the error bars overlapping? And are the 2 data sets significantly different? I incorporated dashed lines to guide you through this subject. The pink area is where the column bars, including the error bars, don't overlap. This means that if a data point were to only fall in the colored area, we would be able to assign it only to the orange column. This would be a good sign that the data sets are significantly different. However, additional statistical tests are needed to confirm that conclusion. If the error bars overlap, we wouldn't be able to distinguish between data points from the different data sets, likely making them non-significant. Now that we discussed this, let's add error bars to our chart. Making sure your chart is still selected, under the Design tab, locate the Add Chart Elements dropdown. Then Error Bars, which gives more error bar options. Select Sex 1 and click OK. This opens a side window allowing you to look at all the options regarding the error bars. I want to point out that within the sidebar, there are 3 tabs to choose from. If for some reason the option you want are not showing up, make sure you are on the right tab. You want the Options tab. From here, make sure you select both directions with an end cap. Customize the standard deviation values by selecting Specify Values. Highlight the standard deviation values from the formulated table for Sex 1 for both the positive and negative error values. Then click OK. Now, you have to repeat this whole process to incorporate error bars to the columns of Sex 2 bears. Afterwards, you can answer the question in the assessment sheet. So feel free to pause the video now. No graph is complete without a title and axis labels. To put those in, we again go into Chart Tools and Design, and on the far left, you see Add Chart Elements. When you click that, there is a large drop-down of options. Select what you want to add and enter the value in the function box. In this case, I select the chart title option. This provides additional options for the title location. If you already have a title in your chart, you can easily edit the title by clicking on it. This is the last subject regarding the bar graph. Now, onto scatter plots. We want to look at the relationship of weight with age of the bears. So we have selected a relationship scatter plot. For scatter plots, you also need to know the series as well as the distinction between your independent and dependent variables. The series for this example will be Sex 1 and Sex 2, just as with the column graph. The independent variable always goes on the x-axis, the bottom, while the dependent variable goes on the y-axis, which is the vertical axis. To distinguish between your independent variable and your dependent variable for the y, you have to ask yourself which variable cannot be changed by another variable. For example, age or time. Neither can be manipulated no matter how much experimentation you do. This would be the independent variable compared to the dependent variable, which can be affected by another variable or other factors. An easy way to remember which variable is which is to insert the names of the 2 variables you are using in the way they make most sense into this sentence. Independent variable causes a change in the dependent variable, and it isn't possible that dependent variable could cause a change in the independent variable. In our case, we want to examine the relationship between age and weight within each sex, which makes more sense. Age causes a change in weight, and it isn't possible that weight could cause a change in age, or weight causes a change in age, and it is impossible that age could cause a change in weight. You choose. In this exercise, age is the independent variable since there is nothing you can do about that, and weight is the dependent variable since weight could depend on age. The older you are, the larger you are, right? To create this graph, we're going to do this on the All Data tab because we want to see how the individual values are distributed in relation to each other. Some of the basics are the same as with the column graph, so I'm not showing you those detailed steps, but rather just pointing out where the steps are different. You'll notice that I already started this graph for you for Sex 1. I'll walk you through what I did to get to this point, then you'll just have to add Sex 2, just like you did before. The first thing I did to start the graph was to click on a blank cell, then insert chart type and select scatterplot. In order to incorporate Sex 2 into that graph, make sure your graph is highlighted. Then select Chart Tools and the Design tab. And finally, click on Select Data. Notice that sex1 is already in the series. You can then add the sex2 series, just as you did for the column graph. You'll notice this pop-up is a little different than what you saw in the column graph. This time you have the option to select both X and Y value ranges. You'll start by entering the series name. I put sex1. You'll put sex2. For the x-axis, we want to select all h values for the values within the series. So I selected all of the h values for sex1. For the series y values, you'll select the weight data points. Again, only for the series you are interested in. When you hit OK, you should now see data points for both sex1 and sex2 on the same graph. If you need more time to incorporate the values of sex2 bears, go ahead and pause the video at this time. So once you have both sexes plotted on your graph, you can add a trend line. This will allow you to see the overall slope of the line and give you a visual as to the prevailing relationship among the plotted points. You can also see the R-squared value, which gives you a quantitative assessment of how well the trend line represents the actual points, and an equation for the slope of the line. To add a trend line, make sure the chart is selected so that you can select Chart Tools and have the Design tab available. Then you can select Add Chart Elements. In this case, we're adding a linear line, but which type you choose depends on what your question is. If you add a trend line to a graph that has more than one series, Excel will bring up an option for which series you want to add. You'll select sex2 since I already did this for sex1. After the trend line is added, you can right-click on it. Then select Format Trend Line. As before, there are 3 tabs within the sidebar. Make sure you are on the Options tab. From here, you can also change the relationship if you've selected the wrong one, or verify that you selected the correct type. This is also where you can select the options to display the equation and R-square on the chart. Take a second to do this for sex2 and answer the questions in your assessment sheet. You can pause the video at this time. Now that you know how to create nice tables and graphs, how do you move them into other platforms? You went through all this for a reason, right? So most likely you need to move that information into your paper or report. The most common places you'll want them in are Word and PowerPoint. You just click or highlight what you want to move, you copy it, and you do a special paste. You can actually select Paste Image, which is shown in the screenshot, and that should give you the last information to answer the last assessment question. Lastly, ExcelEasy.com is a great website that goes over a lot of the basics, and you always have the YouTube videos that you watched in your pre-workshop basics and this video through the ACE website, along with the supplementary material for sort, filter, format, and entering data. We hope this workshop has made you more comfortable with Excel and helped you learn a few tricks to make things easier in your data management adventures. Please take some time to complete the exit survey available under the Survey tab in your Excel file. We value your input. Thank you.